All right, well, let's get started. Hi, everyone. Welcome. My name is Ali Mobrem. I'm a product manager here at Red Hat, specifically on the OpenShift team. Today, I'm going to be presenting for you guys OpenShift 4.0 update and kind of going through and showing you all the cool stuff that we're going to be releasing in OpenShift 4.0. All right, so here we go. As you guys all know, we purchased a company called CoreOS about a year ago. And they had their own Kubernetes management platform called TECTONIC. So ever since we purchased their company, we've been hard at work at grabbing the best parts and bits out of their solution and bringing that into OpenShift. So OpenShift 4.0 is going to be kind of a unified OpenShift platform. We're going to bring all the good stuff in. Things like we've really adopted the CoreOS operator pattern. We were using their framework to enable us to do that. What this gives us is a lot more automation in the new 4.0 OpenShift. So everything's going to be automated. Other cool things that we're going to get as well is we're now going to a immutable stack. That's some technology we've gotten from CoreOS as well, and that's also going to allow us to start doing things like over-the-air updates. So CoreOS had a lot of great technology and ideas and stuff, and we're fully embracing that and adopting that and bringing it into OpenShift 4.0. So one of the first questions most people have is, what's the timeline? What's the roadmap look like? And I thought I'd just start off right off the bat for everybody. So OpenShift 4.0 is going to come out in April. That's our target date. It's going to be chock full of a lot of great things. We're going to have, like I talked about, we're going to have the immutable host. We're going to have over-the-air updates. We're going to have things like OPERATORHUB available. I'll talk about a little bit later. Istio, Knative support, metering, chargeback. So a lot of great stuff. One thing to note, though, for the 4.0 release, we're going to be focused on just releasing on AWS, right? And we did that for a reason. Our thought process there is let's really nail it down for one platform before we start moving on and getting OpenShift 4.0 on all the other platforms. We're having a very quick follow-up release in about May, June that will move OpenShift to all these other platforms, right? Normally, it's not our normal release cycle. We're going to do a very quick, short release to get all those other platforms up and running as soon as possible. So that'll happen in May, June. And then after that, we're going to go back to our normal release cadence. So the next thing I wanted to talk to everybody about is right now you could go ahead and download and install OpenShift. Just go to try.openshift.com, log in with the Red Hat credentials, and you should be able to go ahead and try this. Again, this only works on AWS. It's a developer preview. Some caveats that I want to give you: do not install this on your production AWS. We don't want anything to get messed up there. By the way, the install actually needs a lot of AWS permissions. It needs things like Elite 6 Elastic IP. So if you have a very just basic AWS account, you're going to have to request some more resources from AWS to get the installer to work properly. But the cool thing is, like I said, you can try it today. So feel free to go to try.openshift.com and download the installer. And we'd love to hear any feedback you guys have for us. You can reach out to me at amobrem at redhat.com. So that's AMOBREM at redhat.com. That'd be great.
Hello. I see what you mean. You can't just do stuff from this, which is
everything is terrible.
I'm sure.
Someone is speaking. All right, here we go. So now, for OpenShift 2019, our big themes are the following. We have unified hybrid cloud, we have day 2 operations, we have OPERATORHUB, and we have management for OpenShift. So unified hybrid cloud is what was going to be our multi-cluster management. It's going to allow you to see all your different clusters. It's going to allow you to create clusters straight from UHC. For the first version of this, it's going to be a SaaS offering. So we're going to start off with a SaaS offering for multi-cluster management. Probably later on in the year, we'll come up with a on-prem version of that as well. The next big thing for us is day two operations. And with day two operations, it's all about automation, right? So we're automating everything specifically with operators. We're automating the creation of machines and provisioning, essentially enabling you to grow and scale your clusters. We're improving infrastructure controls for everybody. Essentially, our goal is to try to get to like the self-managing stack, and that's what our day two operations is about. The next big thing for us is Operator Hub. Operator Hub is where you're going to find all this great content. We're aggressively going after ISVs to really produce services and products that you'll be able to utilize and discover through Operator Hub. So expect a rich ecosystem of partners to be provided for you. Operator Hubs are literally going to allow you to grab whatever operator you want, bring it down into your platform. This is going to allow you to customize your platform, specifically if you have like AI workloads or big data workloads, or you're creating intelligent apps, or you need dev tools. You'll be able to go discover all that kind of good stuff on Operator Hub, and then bring it onto your OpenShift platform and use it that way. And for our last big theme that we're going for, it's management for OpenShift. And essentially, we're really trying to focus on how do we make that easier for you guys. We're giving you things right out of the box, like Prometheus for cluster-wide monitoring and metrics. We're adding metering in there. We're adding cost management. We're giving you enterprise security. Essentially, the focus there is really focusing on giving you guys an enterprise quality stack. Now, specifically for OpenShift 4, right? We're focusing on these three buckets, bringing it all together to give you guys an orchestrator platform that's going to be kind of comparable to managed environments like EKS, AKS, and other hosted Kubernetes providers, right? So FYI for all you like OpenShift 3 users out there, this is kind of going to be very different from what you're used to. We've added a lot of automation and improvements to get us to where we are for this release. We've added things like simplifying the installation. We're initially focusing on just installing it in AWS. The workflow is going to provision all the infrastructure for you so that you get auto scaling out of the box. You can also use things like machine sets to create node pools that are specific for like GPU or high CPU workloads. So we're automating the scaling and growth and kind of the creating of the machine sets, all for our day two operations. Again, this is kind of all being powered by the operator theme and all the automation that we've added in there for the day two operations. The next big thing is the immutable infrastructure bucket, right? So we're focused there. We were coming up with RHEL CoreOS, which is a new immutable version of RHEL. It'll give you capabilities like over-the-air updates. This is one of the reasons why we're kind of discouraging people now from SSHing to nodes. In fact, if you guys now SSH to a node, we will mark that as tainted. And the whole goal here is to prevent like someone going onto the system, changing some kind of settings or security or whatever, without the system doing it itself, right? We don't want you guys to get any snowflakes. We all know like what happens when you get snowflakes and drift in your configuration. Problems arise, and it's very hard to troubleshoot and audit what you have exactly. So our whole goal is to discourage that kind of behavior and really have an immutable stack that Kubernetes and OpenShift are going to manage for you. Last but not least, we have our next focus was the operator framework, right? And the power of the operator concept. With 4.0, we're delivering enhancements to the SDK already available. I can't emphasize how important the operator stuff is. We took the operator platform ourselves and used it to rebuild Kube and OpenShift stack for you guys. This translates to us creating 40 plus operators kind of essentially power OpenShift for you. The next thing on the list here you see is we have the Operator Hub. Again, I talked about that a little bit earlier. It's going to be a great way for you to discover community operators and services, as well as Red Hat certified operators. And then we finally have OLM, which is the Operator Lifecycle Manager. Essentially, that's going to enable you to manage and update your operators. So at a certain point, if you guys go and start creating operators yourself on the platform, this will be the mechanism that will allow you to do over-the-air updates for your own applications and services running on Kubernetes. So these three buckets together essentially bring together what I like to call like the next generation of the Kubernetes platform. All right, so let's talk a little bit about immutable infrastructure, right? So essentially for OpenShift 3, you had OpenShift platform, and then you also had the operating system. So back in the day, you'd have to rely on an admin to come and install the OS, configure it correctly. Later, you would then lay down OpenShift platform on top of it. Say you patch the operators, the platform, or you patch the OS. These could be in different maintenance cycles. So it was two different systems, but in reality, it should be one, right? So again, with OpenShift 3, we felt like people were getting a lot of configuration drift, and snowflakes were happening in the system. So now with OpenShift 4, we've identified that it's critical to link the platform and the OS together to make sure that the platform is stable and consistent, and to simplify things like scaling out your cluster, right? So what we did is we created an API-driven connection between the two layers, and we redefined the system. So we go all the way down now to the operating system. So we see how important it is to bring it all together and to make sure nothing's disjoint for you guys. One of the things, though, is in order for this stuff to work, for the data management stuff to properly work, we need kind of full control over your nodes, at least the master nodes, because that's what's going to allow us to go from point A to point B. We have to know exactly what's there in order for us to be able to use over-air updates to upgrade for you guys to the later version of the cluster. So that's going to be very important there. So I also want to talk a little bit about what immutability means. It means repeatability. It means auditability. Sorry. Because of this, like the next node you add to your cluster, it will be the same, right? So you can now repeat the same process with confidence. Also, with larger clusters, you want to be able to say audit changes, and rest assured that there's no special nodes with configurations that differ from other nodes, right? So again, you want your different clusters to kind of match up. You want the nodes on each cluster to match up, and it's all about giving you that peace of mind. What immutability does not mean, right? It does not mean it's a static cluster. In fact, it means it'll be easier to grow your clusters in a controlled and systematic fashion, right? You can still change and configure environments, obviously, but now the cluster is aware of those changes, and those changes are actually applied uniformly to all the nodes. So, I mean, this is day 2 talk, but in reality, let's talk about like day 365. Imagine your admin leaves, and now you need someone or a new admin to come in and add 5 nodes to the cluster. Well, this kind of solves that problem, right? The new admin doesn't have to go and find the previous installation scripts, hopefully it's version somewhere. They don't have to guess any of the configuration settings. Instead, it's all now contained in the cluster and easily accessible. So this is some pretty cool stuff, if you ask me, that is really going to kind of add to the stability of it. All right, so next I want to talk about infrastructure provisioning. We've come up with 2 new terms. One is called user provision infrastructure. The next is called installer provision infrastructure. So in OpenShift 3, you were only able to do UPI, right? User provision infrastructure. And that means, for example, if you're going to deploy to AWS, you had to manually go create the VPC, you had to go create your security groups, your EC2 instances, you name it, you had to create it, and then at that point you would then lay down OpenShift on top of it, correct? With IPI, the installer provision infrastructure, with OpenShift 4, we're now giving you a single-click installer. You just give us access to AWS, and we'll go VPC, security groups, load balancers, elastic IP addresses, all that stuff that's needed to create and run OpenShift for you guys. We'll do it. And that's going to be the default installer for OpenShift 4. But we know some of you have some special configurations or security and issues that maybe you don't allow us to go and create VPCs for you. A special group does that at your company. We'll at that point let you guys configure that stuff yourselves, and so we'll provide you a UPI. So let me show you guys what the roadmap for that is. Right. So in 4.0, which is coming out in April, you're going to get AWS IPI, right? Install provision infrastructure. Our goal then for 4.1, which is a very quick release right after in the May-June timeframe, is going to give you AWS using UPI, VMware, and bare metal support via UPI. 4.2 is then going to come and give you IPI installation for Microsoft Azure, Google Cloud Platform, Red Hat OpenStack Platform, and bare metal on Rye, right? And then in OpenShift 4.3, we're going to give support for Alibaba Cloud, and then we're going to give you UPI support for Microsoft Azure, Google Cloud Platform, and Red Hat OpenStack Platform. So expect all those platforms to be added in the near future. All right, so let's talk a little bit about the new install experience, IPI, right? I mentioned earlier in the slide before that you can download it at try.openshift.com. And then here are a couple of commands, right? So the first four are essentially, hey, give me some help on this command, and let me see the configuration files and the manifest files that you're going to use to create in AWS. If you want to go and play around and see what is actually going to happen to your AWS environment before you run the create cluster, go ahead and run those commands. It'll generate all the config files for you, so you can play around and see what's going on. And then after that, just run the OpenShift install create cluster. And with that one command line, you will have a cluster generated for you. It usually takes anywhere between 15 to 30 minutes to 15 to 20 minutes, I'd say, to get the cluster going. And then if you ever want to take the cluster down, you can just run OpenShift install destroy cluster, and we will build a cluster for you. A couple things to note. This new install is essentially just a Go binary. You could get it at download.try.openshift.com, and then this does not work for upgrades. So this is just for a new installation. All right, so let's talk a little bit now about, so that is try.openshift.com was where you could get download the installer. We also have a new SaaS portal called UHC, the Unified Hybrid Cloud. That's what I talked about earlier about having that multi-cluster management. We're going to have the ability for you guys to create AWS, Google Cloud, Azure, or on-prem clusters right from there. You'll be able to see all your registered cluster from that single pane of glass. You'll also be able to update your clusters, right? So as you can see in the screenshot on the top right, it shows that some of your clusters are ready to be upgraded and what version they're at. So you're going to get all this great information in a single pane of glass, and that is going to be released with 4.0 in the April timeframe as well. And the URL for that will be cloud.openshift.com. Once again, it's cloud.openshift.com, and you'll get to see your multi-cluster management system. Remember, though, for 4.0, we'll only be supporting AWS clusters in the beginning, but once 4.1 to 4.2 come out, you'll get a lot more options there. All right, so now that you have your cluster up, right, let's talk a little bit about scaling your cluster out. There's a brand new cluster API. We at Red Hat have been working with the Kubernetes working group and contributing back to this a lot. It's got 3 kube primitives right here, right? So you got machine deployment, machine set, and machine. I want you guys to think of machine deployment as a regular deployment, machine set as like a replica set, and then machine as a pod, right? So if you think of those in parallel, they behave very similar, right? So now with machine sets, you could say, hey, I want this set of machines in this availability zone. Um, so to go ahead and deploy that set of machines out for me. And the machine deployment is what's going to be driving all that. So here's a screenshot of the list of machines here, right? So you're going to see in our cluster, we created 3 masters. We created also 3 workers. You can see what availability zones that they're in. And so as you expand your cluster, you'll be able to see the scale up and down as your needs are needed. Now, here's a screenshot of machine sets. As you know, there's no masters in this list. It's only a list of workers. So we don't allow you right now to create machine sets for the master. We treat the masters as special. We don't want you guys to mess with the master just because it could actually bring a cluster down if someone accidentally scales it back or something. So another interesting thing about the screenshot right here is you see there are 6 availability zones, but only 3 of them have machines. And what that means is you wanted to provision 3 machines. The cluster API came in and chose 3 availability zones for you and deployed those there. But you still have 3 more availability zones if you wanted to go ahead and roll out more machines to those different zones. So this gives you a nice view of that. And expect some more enhancements. We'll be updating this shortly with like adding more information of connecting machines to nodes as well. All right, so here's an image of a possible cluster architecture, right? So here in the top left, you've got the control plane where all your masters lie. Again, this is an AWS architecture specifically, right? So you're going to have M3 extra larges for your masters. You're going to have M5 larges for your workers. And you're going to have, for logging, you may have R5 2XX large. The reason for that is, say you want some high performance systems to handle all your logging and monitoring needs. You need to be performant. So you could go ahead and create a machine set that just focuses on adding more specific types of machines like that to your pool of machines right there. You also have routing over here on the far right, which is M5 large. But you know what? It is exposed to all the routing systems are exposed to the external internet. So you may have a bunch of special security settings on those machines. So at that point, it's going to be like a different set of machines you're going to roll out, and so you'll create a unique machine set specific for that, or deployment for that. So as you see here, we have different types of machine deployments that I kind of showed you guys. There's the worker, the login monitoring, the router. You could scale out each of those machine deployments independently. You could set the desired state in the cluster. Auto scaling is you get that for free with this. And then it also does rolling machine config updates. The other cool thing too is like if you have, say you're doing some animation or AI or something and you need special GPU machines, you can go ahead and create a deployment for that. And when your special job type goes, you could use taints and tolerations to drive those workloads to those specific machines and scale up and down as needed to run all that work. Same with special security or special anything. You just make a machine deployment of that type and use taints and tolerations to drive specific workloads to those special machine deployments that you may have. All right, so we just talked about how to scale and grow your cluster. Now I kind of want to talk about updating cluster, right? So here's a screen I want to show you guys. It's under administration. It's a new thing. It's called cluster settings, and we're on the overview page right here. And you're going to see a bunch of cool stuff. You're going to see it, for example, you have a channel. You can update the channel. So say you're on a dev cluster, you can set it to fast or nightly, and we can auto update that cluster for you. As soon as updates come, your cluster will get updated over the air. You guys have to do nothing there. You could also set it to be production and do manual updates. So if you want to wait to a production release is released, then once it is, we'll notify you guys that, and you could do a manual update. Other cool things you can see on the screen is you have the ability to create an autoscaler. You also have update history. So you can see the history of how this cluster was updated and what the current version is at right now. So you'll be able to update your cluster from this page here, right? Or if you're using the UHC and cloud.openshift.com, you'll have an interface there to update your cluster as well that will look essentially very similar to this as well, right? So you can either update from the multi-cluster manager or from the cluster itself in this cluster settings page. Now, the next thing I want to show you guys is global configuration, right? Before, your cluster configuration could have been some Ansible file, and now it's actually part of the cluster and it's one source of truth, right? So we have all these operators that are now making up the cluster. We're surfacing all their configuration for the cluster-wide stuff right here. You got authentication, DNS, image registry stuff, infrastructure, ingress, OAuth. For example, like if you guys want to come and set up a new identity provider, you would go update the setting right here. So you could add either HT password, GitHub, LDAP, whatever identity provider you guys want to use. This would be where you would update that. Cool thing here is as we add more operators to the system and surface more configurations, expect this area to expand and have the ability to configure more and more of the cluster in OpenShift here. All right, so the next thing I want to show you guys in the cluster setting pages is the cluster operators. This is essentially where all the top level cluster operators that run your cluster are. So we're all in on the operator model, right? We operatize the entire stack, and this is it, right? This is what's enabling us to do over there updates. It's a really powerful pattern, right? You're going to see all the different operators on your left-hand side. You'll see the status. You'll see any message come back from the operator here, be surfaced here, and you'll also see the version of that operator running. One of the cool things is, for example, let's say you're doing an update, and there's one of the operators fails to update. You will see which operator it will be, and the rollout will be paused at that point. So, we definitely don't want to hurt your cluster. So then at that point, the rest of the operators will be rolled back, right? But this will give you, the status of how your update is happening on this screen. So again, we're all in on the operator framework and pattern, and we've rebuilt and architected all the kube and OpenShift services using it. So something that's very cool and very powerful. All right, so as we talked, this is all day 2 operation stuff, right? So first we talked about the machine operators, and the machine operators, we're using that to grow your cluster, add nodes to it, to auto provision from your cloud provider, all that great stuff. Next, we talked about the cluster operators, like what OpenShift and Kube is using to run, and it's powering the entire cluster. And then the last thing I kind of just showed you guys was the over there stuff, and we're using update operators to manage and run that for us, right? So these 3 sets of operators are really what's giving us that automation and then day 2 operation stuff. So really cool stuff, and really powerful in my opinion. So let's kind of go in and break down operators if you guys weren't familiar with it before. I've used the term a lot throughout this presentation. And so, right here it says operators equals automated like the cloud, right? So like on AWS, if you have like a hosted service that AWS is running, they either have a bunch of automation or people behind the scenes managing that service, right? So now with operators, you can kind of build in that operational knowledge and smarts into your application or service, right? And make sure that your application is running smoothly and efficiently. But the nice thing is now, because it's all kind of packaged in the operator, your operator isn't tied to just one provider. It can run on any Kubernetes stack. It can run on OpenShift. So you've actually created something that's very much more portable, right? So the full definition of operator is a method of packaging, deploying, and managing Kubernetes applications. A Kubernetes application is both deployed on Kubernetes and managed using Kubernetes APIs and kubectl tooling, right? So the operator is really giving you portability. One of the other great things about the operator framework is we've really automated the lifecycle management of your service or application, right? We've come and operator codifies your service management, right? The operator will handle your installation, it'll handle upgrades, it'll handle backups, it'll handle rollbacks, even tuning if you build that in there, and failure recovery, right? So the more operational knowledge you put into your operator, the more solid and scalable it'll be. Again, a really powerful concept of building all that operational knowledge that you guys have for your own applications or using operators from somebody else. They've built in all that into it already, so you're going to get the best service possible. Another really cool thing about operators are built on CRDs in Kubernetes, essentially custom resource definitions. CRDs are considered Kubernetes primitives, right? So you can easily plug into existing kube workflows you may have, be it through the kubectl command line or even OpenShift console. So operators equals native Kubernetes experience. All right, so let's talk a little bit about the operator framework. The operator framework is made up of three pieces, right? SDK, lifecycle management, and metering. So the SDK enables developers to build operators based on their expertise without requiring knowledge of Kubernetes API complexities, right? We're trying to make that easier for other types of developers to bring their service to Kubernetes, right? The next piece in the puzzle is the operator lifecycle manager. This oversees installation, updates, and management of the lifecycle of your operator and their associated services that go along with it, running across Kubernetes clusters. So the OLM is really going to give you that over-there updates for your services. So when you're consuming somebody else's operator, this means that they could go ahead and update it for you seamlessly, or if you guys are creating your own applications in-house on top of the Kubernetes and OpenShift platform, you'll be able to go ahead and utilize this to update your own apps and services that you guys have created in-house, right? The last piece here is the operator metering. This essentially enables usage reporting of the operators back to the creator of the operator. All right, so now I kind of want to talk about Operator Hub, right? So Operator Hub is essentially our portal that allows you to discover and enable Red Hat products and service, ISV partner operators, and community operators, right? So you'll get that through the Operator Hub. One of the cool things about Operator Hub is Operator Hub allows admins to pick and choose apps and services that will be available for the users via their dev catalog, right? So if you're an admin and you only want to allow a certain set of services to show up for your users in the dev catalog, you now have the power to choose which services will be there, right? There's going to be two versions of the Operator Hub. One's going to run locally on your cluster, which is the top image, and then we're going to come up with online property called Operator Hub as well, and that'll be coming out shortly. That'll be available to everybody as well. All right, so with the Operator Hub, it really allows us to kind of customize our OpenShift platform, right? So one of the big complaints we got was OpenShift was a bloated thing of Kubernetes, right? So what we've done now is we're slimming down the default install, and we're allowing people to do incremental feature buy-in, right? So the Operator Hub is allowing us to do that. So with a new install, out of the box, you're going to get console and authorization stuff. You're going to get monitoring. You're going to get the ability to over-the-air updates. You're going to get machine management, all the kind of cool stuff I showed you guys previously. But what's new is the service worker stuff is going to be optional. So if you want to use that, you just enable it via Operator Hub. You want to use other OpenShift components, you can enable that via Operator Hub. Other Red Hat products, ISV partner operators, community operators, there'll be a full catalog of items that you guys can add and customize your platform with. So now what that does is we've created an operator-powered UI extension mechanism, right? So in the middle, you've got the core platform, which is going to give you the ability to do all your Kubernetes management or OpenShift management, right? On the left, we have the dev catalog. That's where we're going to allow all your users to see what services you as a admin have enabled for them, right? So they'll be able to see what operators are enabled on their in their namespace or globally, right? Another thing too is, for example, we have Service Mesh, which is our product version of Istio and Kiali, and if someone enables that operator, we're now going to create external application launcher to go to Service Mesh, so you can now do network what's it called, microservice network management. So you'll be able to see all your container-to-container networking via Service Mesh. And once that operator is enabled, we'll enable a link to that UI, and you'll go right into context of that namespace per se, right? Another item here is CNV. This is our KubeVirt productized, and now if you go and download that operator, you will be able to manage virtual machines. It's not going to be a secondhand experience. It's going to be a native experience right in the console, and it's once that operator is enabled, all that great stuff is going to become visible to you guys, and you'll be able to run and manage your virtual machines straight from OpenShift. Other cool things we have is native plus external links monitoring, right? So for monitoring, we've actually brought in some of the monitoring stuff natively, right? So we created some screens that give you native look and feel for alerts, right? So you can look at all the alerts in the system. If you want to go and look at more detail, more complexity, you can actually use the external link to go back to Prometheus or Grafana or whatever the full-blown dashboard is that's external to OpenShift. But we're trying to also give you a native experience at the same time and bring in that functionality. And last, on the right, we have metering and chargeback. Again, by default, it's not going to be available to you. You just have to go to OperatorHub, enable it. Once it's enabled, again, you're going to get a full native experience, and you're going to get all the metering and chargeback reports. All right, so let's talk a little bit about the developer catalog. I mentioned it briefly in the previous slide. So the developer catalog is a redesigned catalog that will bring all the new operators and existing broker services together. It'll be a new way to discover, sort, and understand how to best use each type of offering. This catalog of operators will be what the admin makes available to you, right? So you're going to get, all the operators there, the service catalog items there, the STI, that stuff will all be surfaced to this new developer catalog that you're seeing right here. So we kind of brought it all together into one pane of glass for you guys. Next thing I want to talk about is Service Mesh. So this is essentially our productized version of Istio. It's comprised of multiple components, right? You're going to have on the bottom left a topology UI called Kiali. That is going to give you the topology view of your service mesh, so all the networking between all your containers and pods. Next, on the top left, top left, you're going to have Jaeger, which is going to give you all the tracing capabilities. And then on the right, you're going to have both Prometheus and Grafana UIs that'll show you metrics from all this. And Istio itself will allow you to secure and control how traffic flows between all the different applications in the namespace and so forth. So you're going to get a really powerful tool, and all you have to do is enable it via OperatorHub. And once it's enabled, we'll then add that external link that will link you to Service Mesh and context, right? So cool stuff here. Next thing I want to talk about is chargeback, metering and chargeback, right? Currently, it's in developer preview right now. You install from OperatorHub. The nice thing about this is we could tie back to the cloud providers billing API, right? So in the bottom right, you can kind of see that you have a little matrix there, right? So you can see we have reports for you that'll give you like CPU utilization against either a pod, namespace, node, and so forth, right? So all those reports will come out of the box for you guys. You'll be able to schedule reports. That'd be cool. You'll be able to create custom reports as well eventually. So this will be super powerful to tell you guys exactly, what kind of costs and stuff you guys are getting from the cloud providers. You can even use this to like start shaming back teams if they're abusing the system and using more resources than all the other development teams, for instance. So yeah, so that'll give you all those capabilities right there. Next thing I want to talk about is cluster monitoring in 4.0. Out of the box, we're going to give you cluster-wide monitoring experience. That's going to come right out of the box, and that's the left-hand screen. But on the right-hand screen, we're also going to let you provision Prometheus per namespace, so teams could go ahead and do application monitoring just for the application, right? So you go to OPERATORHUB, you're going to go ahead and subscribe to Prometheus just for that namespace, and then now the development team has their own application or namespace-wide monitoring, and the admin has their cluster-wide monitoring available right out of the box as well. All right, so let's talk a little bit. Last thing I want to talk with everybody for 4.0 is the upgrade plan. Some of the feedback that we've gotten from customers are customers don't like to do serial upgrades. Who does? Customers would like to have a recovery process and be able to automate rollback if there's some kind of failure. And the other bit of information that we got is customers would like to actually migrate applications between different clusters, right? So what that leads us to is, maybe the upgrade path isn't the in-place upgrade isn't the way to do it. Migration utility might be a much better solution, right? So with a migration tool, we can focus on cluster and project configuration. We'll start targeting the configurations that build up over time and move that over to the new cluster. We'll grab all the contents in your registry and either move that to another internal registry or to Quay for you guys, external Quay. And then application workload stuff. We'll capture workloads, move those over. We'll grab, persistent volume, content, move that stuff over for you guys. So the cool thing here is, you could have both your 3x cluster running and 4x cluster environment running in parallel. You can move everything over, have it running in parallel for a while to make sure everything's working as planned, and then you can bring down your 3x cluster, right? Another cool item I like is that once your 3x to 4x migration is done, later you'll be able to use this utility to migrate your application from 4x to 4x cluster. So if you have multiple clusters and you want to migrate your application, you'll now be able to do that between clusters as well. So that's it. Thank you all for your time. I really appreciate you guys coming out and listening to me today. Hopefully all this information is useful to you guys all.